Right, you're recording.
All right. Welcome, everyone. My name's Don Graham. I'm the LMR Communications Market Manager for Viavi Solutions. And I'm here today to talk about improving the end-to-end reliability of mission-critical LMR networks. This drawing is an example of a basic LMR RF site configuration. I know there's different types here, but this is, depicting a basic one, generic RF site. Mission critical networks require well-tested and calibrated infrastructure repeaters, as well as subscriber radios. End-to-end reliability also requires properly tested and certified copper infrastructure installations and regularly maintained backhaul networks. Viavi is the only vendor that can supply you with all the test tools needed to maintain the end-to-end reliability of your mission critical network. This slide here's an example of the different testing points of an LMR system and what tools Viavi has to complete the certification or optimization of that system element, whether it's the RF tower, antenna, or transmission line, repeaters, subscribers, dispatch console, the backhaul in a system. Viavi's put together a toolkit that can be carried by technicians in the field to maintain the end-to-end reliability of the LMR network. Kind of looking at this diagram, we'll take a closer look at some of the different testing points that I have listed here in the network and discuss each one and what Viavi tools should be used and why it should be used. The first one we got here is the subscriber radios and the repeaters themselves of a system. And when basically you're going to use a radio test set here to test this part of the system. And when selecting a radio test set, you need to ensure that the test set is recommended and approved by the repeater or subscriber OEM manufacturer. So you want to make sure that this unit is actually testing to their manufacturing specs. Completing automated testing and tuning of a radio that is not done to the exact manufacturer specs is effectively detuning a radio, thus reducing your end-to-end reliability. Here we depict the radios that are in a typical RF site and the subscribers that use the site. The 8800SX digital radio test set would be used to complete the auto test and tune and alignment of a subscriber. And the radio infrastructure repeaters would also be tested with the 8800 and aligned or optimized. And as I mentioned, by completing these tests, you're confirming the radios are operating to the manufacturer's specs. The next thing in line here is we're going to take a look at the antenna system. The One Advisor 800 can be used to test the antenna and transmission line at the site. You know, a lot of people, when the line comes off the truck from being shipped from the manufacturer, they actually do a test right there on the ground to make sure that it, was shipped correctly and wasn't damaged in shipping. Then they'll have it installed by a contractor, and they'll do the exact same test again after it's hung and compare the two, and the customer signs off on that. That's the kind of test that this 800 can do. There's 3 steps, so completing the 3 steps will document the performance of your antenna system. You can measure the performance of the antenna, the loss in the transmission line, and it'll also pinpoint any faults in the antenna system or transmission line. And these tests can be documented and put in the file. So looking at return loss and distance to fault on that diagram right there. The other thing the One Advisor 800 can do, it can be used for spectrum analysis. You can identify interfering signals along with documenting and characterizing your frequency band. So you could actually use this and print out a report that basically shows what it looked like at some time interval, and you could go back and compare it again. It has a real-time spectrum screen and a real-time spectrogram feature built into it, as depicted right there in the slide. All right, now we're going to start taking a look at the backhaul part of the system. There's there's a lot of different configurations of backhaul. We'll cover the top ones here and talk about what tools to use and why. So in this drawing here, this is showing the T1 backhaul. The T-Bird 5800 can be used to measure the round trip bit error rate, or BER, of the circuit, and then you can document its performance. If microwave's being used, as shown in that drawing there, you can use our product called the 3Z antenna alignment tool. This tool can be used to really quickly align the dishes. I mean, it's a very fast alignment tool. And there's also an option on this tool that you can put on the dish and leave after you've aligned it. And it actually it could report into a knock, and you can find out if the dish has moved at all. So it helps you characterize a failure that's coming up. So in this case, with the T1 backhaul, basically a T1 could be copper or it could be microwave. So that's what we're talking about here. And the T-Bird 5800 could, measure that no matter how it is, BER the circuit. Okay, the next one here is Ethernet backhaul over microwave. Again, you're using microwave, so it's the same thing as we talked before. You can use the 3Z antenna alignment tool to align the microwave dishes. And then you could use the T-Bird 5800 to measure the bit error rate of the circuit. And the Ethernet tests that are included in the 5800 are those standards listed there: the RFC 2544, YDOT 1564, and RFC 6349. Each one of those are different types of Ethernet testing standards. The 2544 is like a full pipe test. The YDOT 1564 is more of a priority test, testing VLAN tags and QoS and so forth. And then the 6349 is a true speed layer 4 TCP traffic test. So it has all the standard testing covered there, so you can make every one of those tests. The next one we got is Ethernet over fiber. So we've gotten rid of the dishes, and we're just saying if you have a fiber backhaul now. And there's a couple steps. There's actually 4 steps into doing this. So the first one is to use a microscope to inspect the fiber for dirt before you connect it. At Viavi, we have a saying, they call it inspect before you connect. So before you connect a fiber up to its location, its connection, you definitely inspect it. And the thing to inspect it with is this Fiber Check probe microscope, and it comes with the T-Bird 5800 package. And this definitely confirms that there's no dirt on the connector or the fiber itself. And the pass-fail criteria is based on that standard IEC 61300-3-35. Step 2 in fiber backhaul is you would use a power meter and a light source to measure the optical power of your circuit. The OMK35 could be used to complete the measurement. And that test confirms that your optical power is sufficient so that the equipment can detect proper optical signals. Step 3, you will use an OTDR to verify the fiber is performing correctly. The T-Bird 5800 with the OTDR module will confirm that the insertion loss and the optical return loss are within vendor specifications. And as it says down there, the measurement will actually detect micro bends. So like if guys are like rerouting cable or moving it around and unconnect it and disconnecting it and stuff, or reconnecting it, it'll actually detect the bends in the cable, faulty connectors, and actually splices if you have them in the system. All right, the last fiber backhaul test that we recommend is again using the T-Bird 5800 to measure the bit error rate or the burr of the circuit. It's basically the same test we did before with the Ethernet, but it's over fiber. And it includes the same standards for Ethernet testing that we discussed. And the last one we got here is something that it's kind of, you don't see a lot of it, but it's out there. So Ethernet backhaul over twisted pair wire, copper wire. When you have this scenario, the first test is using the certifier 10 or 40G to certify that the cables don't have any errors in them. And this certifier actually uses the TIA and ISO class standards for copper certification. And then step 2 of that is, again, using the T-Bird 5800 to measure the bit error rate. Pretty much the same test that we've been talking about, third time here. The majority of, I would say, modern RF repeater sites and dispatch consoles are pretty much right now also connected using twisted pair. So the exact same test that we just talked about can be used on both of these system elements. So the cable, the console connections between the dispatch console and the controller, or the actual interconnecting copper network that interconnects the different repeaters to a system. And that is end.
All right. Thank you, Don. I'll open it up for any questions. Be sure to unmute yourself if you're planning to ask a question. Looks like you might not be getting one, Don.
Huh. Okay.
But appreciate the presentation. This will be available for people that missed it, and there are quite a few registrations. We were just short of 500 registrations as of this morning. So I would suspect that we'll have a lot of people viewing the video afterwards on our YouTube channel. It'll be linked to both the Northern California APCO chapter site and the Southern California CPRA site.
Sounds good.
So appreciate your time very much, and I'll stop the recording since there's no questions.